Dear students, this is Manoj Kushwaha. Today we will discuss the augmentation and concentration which we are using in wind turbine design to increase its efficiency and reduce the cost, and also to increase the power output. So first we will discuss the wind augmentation on the design of the turbine. Actually, in wind augmentation, what we do, we make ducts, and these ducted turbines are used for the power generation. Wind augmentation allows the lower trigger wind speed besides the reduced wind turbine size. So as we are discussing this, we can say that the cost for a particular power generation can be reduced if we use the augmentation technique in the design of the turbine blades. The most costly factor for wind augmentation is its tracking and support. But over the recent years, the augmentation of turbine proves the significant performance growth of the wind turbines. The number of blades and the design and the aerodynamics, these all are very important parameters in the design of wind turbine, and basically these optimize the efficiency of turbine and also the extracted power. And few very recent studies have shown that the potential advantage of ducted design are improved safety and protection from the weed growth, and importantly the increased power output and reduced the turbine and gearbox size for a given particular power output. Also, these ducted turbines means after implementing augmentation in the design of the turbines, they are not subject to the beds limit, which is defining the upper limit of the incident kinetic energy to 59.3%, which energy can be converted to shaft power by a single actuator disc turbine in the open flow, which is a limitation. But if we are using ducted turbines, then this limitation is overcome. Also, the recent studies allows to overthrow the various achievements in augmented wind rotor design and the effect of critical parameters on the performance of the wind turbine. You can see also the use of augmented rotor enhance the performance of the wind turbine, and the ducted wind turbines are actually installed at specific regions. So many specific regions are there where the wind velocity is very low, so these ducted wind turbines can be installed there because the ducts can increase the velocity of the wind. These generate electricity as much as the larger conventional wind turbines at a reduced cost. For smaller size turbines, the weight and also then the cost of the duct and the tower have a very minor impact on the overall cost of the turbine system, so that sufficiently high towers and ducts with a reasonable expansion rate can be employed. For this reason, ducted wind turbines, which are also popularly known as DWTs, have recently gained very much attention, not only in the field of high altitude buoyant devices, but also for small sections where small power generation are to be done. Also, basically there are two types of ducted rotors for the wind turbines. One is known as diffuser or unidirectional duct, and the second one is bidirectional duct, in which the duct have the flow in both directions. An initial theory is done based on the momentum and vortex theories, and it is found that the gain in the power extraction for a suitable design of the duct can be at least 65% as compared to the open rotor configuration of the same diameter. It means the power extraction gain, we can say, is quite high if you are using ducted wind turbines, and it has been done from the 300 to 400 years before, in the 17th century, and in that time even the ducted turbines or wind tunnels were designed and implemented. Some specific kind of ducted wind turbines are also used, which are called flange wind turbines. In these machines, the flange generates a large scale flow separation region behind it, where a very low and unsteady pressure zone consequently appears. And in this way, a gain in the mass flow swallowed by the rotor and the power output seems obtainable. The augmentation of the wind turbine enhance the performance of the rotor in the low velocity areas, as we have already discussed, and also the power coefficient doesn't stick with the bed's limit if we are using efficient augmentation techniques, which are very advantageous for the power generation through wind turbine system. Also, some recent developments have been done to improve further the performance of the augmentation factor as well as the rotor performance, and few research have also been done to the ducted turbine performance. You can see here the ducted wind turbine. In this topic, we have already discussed that the ducted turbines proves the significant increase of power coefficient, and also these can be used in low pressure regimes. Since ducted wind turbines are also called as augmented rotor or diffuser wind turbines, earlier stage research has been reported ducted buoyant turbines offers the opportunity to be installed in logistically challenging sites or with poor ground winds, or characterized by a low cost and by a reduced impact on the landscape. Also, ducted wind turbines have the advantage that can be gained by ducting the turbine in is the reduction of the tip loss and the related noise, which is also an additional advantage if we are using ducted wind turbines. The power coefficient of wind turbine rotor can be increased only with the increment of duct thrust coefficient. It is also some insight on the changes occurring to the performance coefficient with the rotor thrust and the duct chamber are obtained through a close inspection of the local features of the flow field. In building augmented wind turbines, which are popularly known as BAWT, the axial direction wind speed is increased through the building. In these turbines, the stream tube is contracted stream by the flow separation from the sharp corners of the buildings. The aerodynamic power output of building augmented wind turbine is quite high in comparison to standalone wind turbine due to the concentration effect caused by the wind speed accelerated. It means if we are using BAWT, then the power output is increased since the wind speed is increased, which is incident on the turbine blades. Here the blade geometry is given, you can see here, and in this you can see how the wind speed can be increased when passing through these blades and incident on it. Concentrator augmented wind turbine is another technology which can be implemented in the design of the wind blades, though the use of this is very limited till date because of few factors. But basically what happens in this design is that the concentrator is used, which is concentrating the wind that incident on the turbine blades, and when it is concentrated, the speed of the wind is increased. And actually few limitations are for these concentrators, and that is one limitation is that they are generally designed for wind speed greater than 5 meters per second, and this limits the choice of physical location where wind farms can be implemented which are using concentrator augmented wind turbine. The concept of concentrator augmented wind turbine, which is popularly known as CAWT, is being considered to improve the efficiency of the wind turbine by increasing the wind speed upstream of the turbine with the help of the concentrator. But since it is not commercialized at a large scale, why? because the wind flow behavior in these CAWT are not known accurately, and also its influence on the turbine power output and the optimum concentrator design parameters are also not known clearly. So the focus is on an extensive review of experimental and theoretical work is to be done on CAWT, means concentrator augmented wind turbines, in order to group the information to help understand the theory behind this technology, and then commercialize this. It has been seen that the concentrator works best when the turbine is just behind the concentrator at a distance of less than 5 centimeter from the concentrator, and also when the concentrator inlet to outlet ratio is being 6. So these kind of studies have been done. Also it has been seen that concentrated augmentation wind turbines are a promising way to increase the power output in low wind speed areas, but their development is being limited since these are specific for use in the areas where the wind speed is more than 5 meter per second. So more works need to be done to understand the wind flow features in the concentrators, and also the wind system behavior in the turbulence, eddies, veer and wake effects, and what are the effect of these on the output power. We know what is turbulence in the wind, means the wind is not flowing steady in one direction, it is flowing in different directions. Suppose it is moving in north direction at a time, then at another time it will be northwest, and like that. And what is eddies in the wind which affects the power output? Actually an eddy is a circulation that develops when the wind flows over or adjacent to rough terrain, building or other obstructions, you can say mountains also. They generally form on the downwind or sheltered side of these obstructions. So these are the eddies which affects the power output. In the same way, veer and wake effects in the wind, we can say what is actually the veer. A veering wind is a wind which turns clockwise with the higher height. An example of a veering wind could be a, you can say, southeast wind at the surface and a west wind at the pressure, you can say 700 millibars. The wind turns in the same direction as a clock from the surface to 700 millibars, you can say this. And what is the wake effect? Wind turbine extracts the energy from the wind, and downstream there is a wake from the wind turbines where wind speed is reduced. As the flow proceeds downstream, there is a spreading of the wake, and the wake recovers towards the free stream conditions. The wake effect is the aggregated influence on the energy production of the wind farm, which results from the changes in the wind speed caused by the impact of the turbine on each other. So this is actually the wake effect. So all these things influence the power output. So that is why the more extensive study need to be done on the wind with turbulence or eddies or veer and wake, so that an optimized concentrator can be designed. So I hope now you understand the concentrator and augmentation in the wind design technology. Thank you.